Hi, welcome to the Learning Loop for TensorThink channel. We present a 30-day series from basics to mastery of TensorFlow. In this series, we cover artificial intelligence, machine learning, deep learning, computer vision, neural networks, natural language processing, sequences and time series prediction. People are charges almost $100 to $600 for this course, but I will teach you this TensorFlow course for free. If your base are not clear or if you are come from non-tech field, don't worry about this. I'll suggest you go to the Code with Harry Python series and then learn Python library like NumPy, Pandas link in bio. Some mathematics formula like variables, coefficients, and functions, linear equations, logarithms, and logarithmic equation, sigmoid function, trigonometry, statistics. If you come from this background, let's learn. If you like to learn more about TensorFlow, then don't forget to subscribe and hit the bell icon. In this video we looking for hello world of neural networks. Computer learning the patterns that distinguish things. Let's look how that works. Now we see some of numbers. There's a formula that maps x to y. Do you remember that y equals 2x minus 1? Here's our first line of code. This is written using Python and TensorFlow and an API in TensorFlow called Keras. Keras makes it really easy to define neural networks. A neural network is basically a set of functions which can learn patterns. Neural networks is just a slightly more advanced implementation of machine learning. Neural network is one that has only one neuron in it, and that's what this line of code does. In Keras, you use the word dense to define a layer of connected neurons. There's only one dense here. So there's only one layer and there's only one unit in it, so it's a single neuron. Successive layers are defined in sequence, hence the word sequential. But there's only one. So you have a single neuron. You define the shape of what's input to the neural network in the first and in this case the only layer, and you can see that our input shape is super simple. It's just one value. Now we understand about optimizer models, but the nice thing for now about TensorFlow and Keras is that a lot of that math is implemented for you in functions. There are two function roles that you should be aware of though, and these are loss functions and optimizers. Let's understand how it's work. The neural network has no idea of the relationship between x and y, so it makes a guess. Say it guesses y equals 10x minus 10. It will then use the data that it knows about, that's the set of x's and y's that we've already seen, to measure how good or how bad its guess was. The loss function measures this and then gives the data to the optimizer, which figures out the next guess. So the optimizer thinks about how good or how badly the guess was done using the data from the loss function. Then the logic is that each guess should be better than the one before. As the guesses get better and better, and accuracy approaches 100%, the term convergence is used. In this video we use the loss as mean squared error and the optimizer is SGD, which stands for stochastic gradient descent. Now our next step is to represent the data. We are using NumPy array. The np.array is using a Python library called NumPy that makes data representation, particularly in lists, much easier. We take two lists of data xs and ys. We have one list for the xs and another one for the ys. Right, so now we predict. Now we're asking the model to figure out how to fit the x values to the y values. The epochs equal 500 value means that it will go through the training loop 500 times. Now it makes a guess, measure how good or how bad the guess is with the loss function, then use the optimizer and the data to make another guess and repeat. After that model has finished training, it will then give you back values using the predict method. Now past it 12. Now you might think it would return 23 because after all y equals 2x minus 1, and you think it should be 23. You'll see that it will return a value very close to 23, but not exactly 23. Why? Because we trained a model using very little data, and there's a very high probability that y equals 23 for x equals 12, but the neural network isn't positive. So it will figure out a realistic value for y. That's the second main reason. Remember this things that when using neural networks, as they try to figure out the answers for everything, they deal in probability. Now working through Hello World in TensorFlow and Python. We see simple example that took some x and y values and figured out the relationship between them. Okay, now we're going to get hands-on with writing this in codes. We use Jupyter Notebooks, or for more better result we use Google Colab. You can find this GitHub profile link in description. Now look at this code. First I am importing and setting up TensorFlow, Keras, and NumPy. Then I'll define the neural network as we discussed. It's one layer, with one neuron and one input value. Now I'm going to compile the neural network using the loss function and the optimizer. Because these will help the neural network guess the pattern, measure how well or how badly the guess performed, before trying again on the next epoch, and slowly getting more accurate. Now we give it the data, where we have a known x and unknown corresponding y, and we want to figure out the relationship between them. These are fed in using NumPy arrays. Here's where we do the training and the machine learns the patterns. We're asking the model to fit the x's to the y's, and it will try for 500 epochs, and each epoch is where it makes a guess, uses the loss function to figure out how well or how badly it did, and then use the optimizer to make another guess. Keep an eye on the loss on the right-hand side. When I start, my loss is quite high, but epoch by epoch, you can see the loss getting lower and lower. By the time 500 epochs have transpired, the loss is really, really small, meaning that for this data, it has come really close to figuring out the relationship between x and y. Now we give it an x that it hadn't previously seen. In this case, 12. It ends up as near 22.98, very close to 23, but not exactly 23. Okay, that's enough for today. Tomorrow I will provide you a assignment and then we working on computer vision. Please hit the like button if you like this video and subscribe this channel for more such amazing videos about TensorFlow. Your likes and subscribe will motivate me.